So I asked ChatGPT to come up with a predicted paper for your GCSE Physics Paper 2 exam, and this is what it came up with. So the first question is talking about moments. So it says define moment in physics terms and give its formula. So I'll just create a space down here so we can answer it. So for question 1a, what is a moment? Well, hopefully everyone should know moment basically we can define as the turning effect of a force. And that should be enough for the first mark. For the second mark, it wants the formula. And so hopefully everyone should know that the moment is going to be equal to the force multiplied by the perpendicular distance. And you can even add here is the perpendicular distance from the line of action of the force to the pivot. Okay. Part B then, a spanner of 0.25 meters long applies a force of 30 newtons. Calculate the moment about the bolt. So we've got 0.25 and 30 newtons. So we're just going to plug into our equation over here that the moment would be equal to 0.25 meters multiplied by the 30 newtons. And that should give you an answer of 7.5. And you do need to also give the units. And so the units for moments is Newton meters. Okay. Right, next topic that you might need to revise for your paper 2 exam that might come up is all about Hooke's law. So you've got the question here, a spring with a spring constant K equals 200 newtons per meter is stretched 0.05 meters. And the first question in A is asking us calculate the force on the spring. So ChatGPT thinks that this question could come up. And so how do we solve this one? Well, we should just know our formula that F would be equal to K multiplied by X, where F is your force, K is your spring constant, and X is your extension. Sometimes this X is written as E as well. So you can just plug in your numbers here, basically very simple. You've got all your units are in the correct form already. So 200 Newton meters is your K multiplied by 0.05 meters. And if you plug that into your calculator, you should get an answer of 10, and the units will be newtons. And then, so for part B, again, we do something very similar. This time we're trying to calculate how much work is done by stretching it. And so remember, work done is just equal to energy transferred. So I'll just write it down here. This is 2B. And so again, you should know the equation that the elastic potential energy you're going to give this spring is going to be equal to half multiplied by the spring constant K multiplied by the extension squared, and this time I write it as E. And so essentially, again, it's just a case of plugging in your numbers. So the spring constant was 200, so you can do half multiplied by 200 multiplied by the extension squared. And remember, the extension was 0.05 meters, and so you just want to square that. And if you plug that into your calculator, you should get 0.25 joules. Okay, and again, the units, you do need them, and it would just be joules. Okay, the next topic that ChatGPT is recommending for us to take a look at is forces and motion. So part A 150 kilo scooter accelerates from rest to 3 meters per second in 5 seconds. Calculate the acceleration. So to do this one, you just need to know your formula for acceleration. So acceleration, hopefully everyone is aware, is the change in velocity divided by the time taken. And so you can just plug your numbers in. So remember, because it starts from rest, that means your change in velocity would just be the 3 meters per second, right? Because the final velocity is 3, so you do 3 minus 0 divided by the time taken, which is given to you as 5 seconds. And so it's just 3 over 5, which is around 0.6 meters per second and squared, right? So you need to know the units for that. Okay, and the next part, it wants us to find the resultant force acting on it. So hopefully the minute you see resultant force, you should be thinking of the Newton's third law formula, which is F equals m multiplied by a, where F is your resultant force, m is your mass, and a is your acceleration. So if you'll notice, we just worked out the acceleration, which was 0.6 meters per second squared, and the m, or the mass, is given to us in the question as 150 kilos. So you should really just be able to plug these in. It should be 150 multiplied by 0.6, and if you work that out, you should get an answer of 90 newtons. Okay, all right, next thing we're going to be looking at is stopping distances. So this is one that a lot of students do tend to get confused with at times. And so ChatGPT has helpfully given us a foundation question and also a higher question for momentum. So for the foundation question on stopping distances, show the difference between thinking distance and braking distance with examples. So it's a little bit different to how it might be phrased in your exam, but you should hopefully be able to define this one. So let's go ahead and make a bit of space down here. We can do our working out. So for question 4, essentially we need to define thinking distance first. So what is thinking distance? Well, this is basically the distance traveled while you're reacting. Okay, so if you think about the example of a vehicle doing an emergency stop, this is the distance that you would travel before you even get to press the brakes. It's the distance that you travel while you're still thinking and you're reacting, and then essentially you get your body to start moving. It's that distance, that's what we call the thinking distance. For the second mark, then basically we want to define braking distance. So I'll just show you guys a question again, just so you know how we're doing this. So show the difference between thinking distance and braking distance. So the first thing we can do is define both of those, and then we can give it two examples to show the difference between each of those, okay? So now let's look at the braking distance. So the braking distance is basically the distance traveled, and this time is basically while you're pressing the brakes. Or you can even put while decelerating. And both of those, according to ChatGPT, should be fine. Basically, this is that distance you travel after you've pressed the brakes, and in that time taken since you pressed the brakes and for the car to come to a stop, the car is going to be traveling during that whole time, and that braking distance is what you call that distance. Okay, so 1 mark. So what they've actually asked for here is how are they different. A more typical question you might get is some factors that affect either of those. Okay, so you can actually point that out. That thinking distance, well, this is a bit different to braking distance, because what is that affected by? Well, thinking distance is affected by things like drugs. So if you take some drugs, or if you're distracted, or you're using your mobile phone, there's all these kind of things that will basically affect your reaction time. Okay, so if you think about what would affect your reaction speed, those are the things that will be factors in increasing or decreasing your thinking distance. And so for braking distance, then these are more to do with physical conditions that might affect your brakes. So things like road conditions, or you can say brake conditions, or you can say tire conditions, and things like that, right? So those are the things that would affect braking. So for example, if you have a really poor road where there's not much friction between the road and the tires, or you have a lot of ice on the road, again, decreases the friction, or your brakes are really worn out, then again, they're not going to be very effective, and those are all things that would increase the braking distance. Okay, for the higher section then, we can look at it down here. So we've got two trolleys, 0.5 kilos and 0.2 kilos, collide and stick together. So let's draw this out. So we have a 0.5 kilo trolley. I'm just going to draw it as a dot because that's easier. So this is moving at 4 meters per second, and it weighed 0.5 kilos, and it collided with another trolley which was initially stationary, right? So you can say over here, this one is not moving, so we'll give it a speed of 0, and the mass was 0.2 kilos. Okay, so that is basically the situation before the collision. So then I'll draw a dotted line over here, and I'll say, okay, what's the situation after the collision? Well, after the collision, it tells us they collide and stick together. And so you can basically draw one big dot over here. You can draw these as two dots if you want, if it's easy clearer to you. So let's do that actually. And basically this has now got a combined velocity and a combined mass. So the combined mass is going to be 0.5 plus 0.2. It's just the individual masses added together, so 0.7 kilos. And the combined velocity is basically what we're trying to find out. Okay, so I'll just put V equals question mark here. And so the way you do this is basically you utilize the concept of the conservation of momentum, that the total momentum in the system before the collision is going to be equal to the total momentum in the system after the collision. So as long as we know our equation for momentum, we can work out the momentum for both of these. So P equals mass times velocity, where P is essentially your momentum. And so your momentum is going to be equal to the mass times the velocity. So on the left hand side, what was the mass and velocity? Well, you have to basically take into account all the different components. So you have 0.5 multiplied by 4. That was the momentum of the first trolley, and that's going to be added to the momentum of the second trolley. But actually we can even ignore that completely, because we know that the velocity was 0. And if the velocity is 0, that means there was no momentum in the second trolley, so we can ignore that. So the total momentum before the collision was just 0.5 multiplied by 4, and that is going to be equal to the total momentum after the collision. So that's going to be the mass. This time we've got a combined mass of 0.7, and that's going to be multiplied by the new combined velocity of which we just called v, right? So now you can see you have 0.5 times 4 equals 0.7 v, and so basically we can just easily rearrange this for v, and so v would be equal to 0.5 multiplied by 4 divided by 0.7, which should be equal to 2 divided by 0.7, which should get you an answer of around 2.86 meters per second. And again, you do need to put the units. Okay, so that is their higher version of the conservation of momentum question that you could come up in your paper. And basically you just apply the formula just like you saw there, where we use the concept of conservation of momentum. Okay, the next question that ChatGPT has got for us is the wave equation question. So a wave travels at 340 meters per second with a frequency of 170 hertz. Calculate its wavelength. So we're just going to use our wave equation, which hopefully you guys all should know. V equals F lambda, where V is your velocity, F is your frequency, and lambda is your wavelength. So we want to calculate wavelength here. So let's rearrange for wavelength or lambda. So lambda is going to be equal to V over F. And so if you plug in your numbers now, V was 340 meters per second. You divide that through by your frequency of 170 hertz, and you should get a lambda of 2 meters. Okay, so that's your final answer. Okay, the next question is asking about the EM spectrum. So list the electromagnetic spectrum in order of increasing frequency. So I won't write this one down, but hopefully everyone is kind of aware. This is just a memory one. So from order of increasing frequency, you start with the lowest frequency. The lowest frequency you need to be aware of is radio wave, and then microwave, and then infrared, visible light, ultraviolet, X-rays, and finally gamma rays, while at the top end with the highest frequency. Okay. Give one use and one danger of ultraviolet radiation. So one use of ultraviolet radiation you could say is tanning lamps. So I'll just write tanning here. And one danger, well, something that it could cause is skin cancer, right? So if you do too much of these artificial sunbeds, they can actually cause skin cancer. You could also say sunburn or even eye damage. You notice when you go into these sun tanning beds, they make you wear these goggles to cover your eyes. Okay, so that's one thing you could say. Right, so the next question is asking us about ultrasound. So explain how ultrasound is used in medical imaging. So you do need to know how the different waves are used, particularly in medicine. So how is ultrasound used in medical imaging? So let's make some space down here. So the first thing with ultrasound is you send in these high frequency sound waves, or you can even just say the ultrasound waves. And where do you send it? Well, this goes into the body. And the idea is that this is going to be reflected. But where is it going to be reflected? It's going to be reflected at the boundaries between tissues, okay? So when you get to different tissues, some of the ultrasound is going to be reflected back. And the idea is you can then detect these reflected waves and process them to form an image, okay? And that's the whole way we use ultrasound in medical imaging. Okay, the next question we've got is on magnetism and electromagnetism. So we want to state Fleming's left-hand rule. So I won't write this one down. But obviously you guys can state it. So Fleming's left-hand rule, basically, when they say state Fleming's left-hand rule, you can just essentially say what each of the parts of your thumb and finger stand for. So the thumb is going to represent your force. Your first finger is going to represent your magnetic field. And your second finger is going to represent your current direction. Okay, so that should be sufficient for the 3 marks. Name 2 ways to increase the strength of an electromagnet. So this is quite a common one that comes up. So one thing you could say is you either increase the current. So I'll just put increase I. Or another thing you could say is you could add more coils. And a third one actually, which is quite popular, is you could add an iron core. Okay, so I won't write that one down. But that is also something you could do to increase the strength of an electromagnet. Okay, the last thing over here then is question 9, transformers and national grid. Explain why electricity is transmitted at high voltages and how step-up, step-down transformers are used in the grid. So this is a pretty common question again. So what is the point of actually using these high voltages when we transmit electricity? That is something you definitely do need to know. So what you can say is when you use this high voltage, this results in a very low current actually. So let's change that. So when you have a high voltage, you have a low current, and as a result, this actually reduces energy lost as heat in the cables, in these long transmission cables, and this increases the efficiency of the energy transfer. So you can even write that. And then the second part of the question is how step-up and step-down transformers are used in the grid. Well, you want to use a step-up transformer before transmission, and basically you can say the opposite for a step-down transformer. So I'm kind of running out of space here, so let's just move this up. You can use a step-down transformer, after transmission, and basically you can even write that the idea of the step-down transformer is to reduce the voltage to a usable voltage in your domestic uses, right? So in your houses or in your offices or in industry, okay? So that would be enough for 4 marks according to this ChatGPT question. So let's see, that's section A. Let's have a look at section B, which ChatGPT has generated for us. Okay, so section B then, a slightly more involved question. So we might involve a bit more writing, more explained type of questions rather than direct calculations. So the first one we've got is all about terminal velocity. So it says a skydiver with a mass 80 kilos reaches terminal velocity. Explain why acceleration becomes 0 at terminal velocity. And it's told us this is 3 marks. Okay, so this again is a very common exam question. So I would expect all of you guys to have revised this And so go ahead, pause the video, have a go. What would you write for 3 marks? Why acceleration becomes 0 at terminal velocity? And we're definitely going to need some space here, so let's do it over here. So one thing we can say is initially the weight is actually larger than the air resistance. Okay, and this results in some acceleration. Okay, so that's your initial acceleration. Then as the speed increases, so I write v for velocity, as velocity increases, the air resistance also increases. And as a result, what happens is you get a decrease in your acceleration because now your resultant force is less. Eventually, you get to this point where the weight is equal to the air resistance. At that point, your acceleration is equal to 0 because your net force, so you can even actually put a step before this, you can say your net force or your unbalanced force is equal to 0, or your resultant force is 0, and therefore your acceleration is also going to be 0. You can even plug in your equation, you can even say F equals ma, so therefore if F is 0, then A has to be 0. Okay, so that would definitely be enough to get you the 3 marks. That answer will probably even be enough to get you 4 or 5 marks if the question asks for it. Okay, so that's how much detail that you want to put, and hopefully all of those stages made sense. And part B then is a calculation question. If her final speed is 50 meters per second and her weight is 784 newtons, what is the air resistance at terminal velocity? So how would we work that one out? Well, we just need to look back at our question over here. We said at terminal velocity, the weight is equal to the air resistance, and it's given us the weight over here is 784 newtons. So therefore, the air resistance at terminal velocity is also just going to be 784 newtons, just like that. Okay. Question 12 then, space physics. Outline the main stages in the life cycle of a star like our sun. Go ahead and write this one out just like we did for the other one. So for question 12 then, the main stages for the life cycle of a star, just like our sun, well, you start off with a nebula, and this develops into a protostar. So remember, your nebula is your kind of your gases, your loose gases, and they eventually pull together due to gravity and become this protostar, which is like your beginning star. This eventually develops into a main sequence star. So this is just your regular star that's going to be, most of its life is going to be spent at this stage. After the main sequence, then it may end up with a red giant. So remember, it's a star about the size of our sun, so similar to our sun, so you can say it turns into a red giant, and then this can then develop into a white dwarf, and that should be sufficient for the main stages of the life cycle of a star, just like our sun. And in fact, when this cools down, you can even say this becomes a black dwarf. Okay, let's have a look at the next question. Explain how evidence from the redshift supports the Big Bang theory. And this one I'll just explain verbally. And so essentially, when you have a redshift, what does that actually show? Well, the fact that the light from galaxies far away is redshifted, this indicates that those galaxies are moving away. And what we actually see is this trend where more distant galaxies show greater redshift. And that tells us that those are moving away at a faster rate. And what that essentially tells us is that we're seeing acceleration happen. And this lends the idea to the theory that the universe is actually expanding. And as a result, this implies that the universe has a starting point. Okay, so from just seeing redshift, we can see that things are moving away from us, and we can see that the further away the planets are, the more the light is redshifted. That implies acceleration, and that implies that they basically have to accelerate from something, and that central point where the universe actually started, that is basically what the Big Bang theory suggests. Okay, so that's why those two would link together. Question 13 then, I've just dragged it down here. Microwaves are used in satellite communication. Explain using the EM spectrum and wave properties why microwaves are suitable. So this is a question basically testing your knowledge of the EM spectrum. You do need to know different uses of the different waves on the EM spectrum and also why they're used in those uses, okay? So microwaves basically, you can say, have a longer wavelength than visible light or infrared. And what you can say is that microwaves are actually very good at penetrating the atmosphere. Okay, so they're not blocked or absorbed by the atmosphere. The frequency range of microwaves basically allow them to pass through the atmosphere, and therefore they can actually reach satellites. And remember, we're looking at satellite communication, so you need to be able to reach those satellites, which are generally in orbit outside of our atmosphere. So you need to go through the atmosphere. One thing you can also say is that they travel at the speed of light in a vacuum, and essentially when they reach the satellites, they reflect off the satellite dishes very efficiently, okay? Which is what you want, right? Because when you're doing your microwave communications, you need to be able to send your signal to the satellite and receive a signal back from the satellite when it's reflected, okay? So that's why microwaves are useful, and that should be enough for the marks there. So next question, electric current does mechanical work in an electromagnet. Identify the energy transfer taking place. So we're just looking at the energy transfer, so only 1 mark. So basically for this, it's an electromagnet, so the energy that comes in is going to be electrical energy. And it's told us that it does mechanical work. So you could say mechanical energy, normally we refer to this as kinetic energy, okay? So this is the energy that essentially is all to do with movement. And essentially, if the electric current comes in and causes the electromagnet to start moving, then that's the energy transfer would be to kinetic energy, okay? You can also actually put magnetic energy here, technically, if there's no movement taking place, okay? The next one then for part B, we can say explain how efficiency could be lost in this process. Well, there's a few ways you can actually might lose some energy here. So remember, when we're talking about efficiency losses, we're talking about energy losses here. And energy losses are simply when we transfer energy to types of energy which we don't find useful. So one of the main things, it could be heat. So you could end up creating heat in the wires. So remember, you're transferring electrical current through these wires, and those wires could heat up, and therefore some of your electrical energy is being transferred to heat energy. So that's sometimes called wasted energy, because we're converting energy to less useful forms. You could also say the coil itself could result in this heat energy as well. So this basically applies to both. And again, within the coil of an electromagnet, you're going to be heating it up. And so again, you're creating you're transferring some energy to thermal energy. And another one you could say in general is if you have any sound or vibrations. So these could be termed wasted energy again. And so this could generally be in the electromagnet itself. If it starts moving, then it might create some noise. And again, that sound energy would be termed an energy loss. Okay, question 15 is an experimental question. So this is the second to last question now. So design a simple experiment to investigate how current in a solenoid affects magnetic field. Strength include independent and dependent variables, how you'd measure the field, and how to control variables. So this is worth 6 marks, but it's actually quite a nicely structured question. So it tells you each of the subjects that you should be addressing, and you can kind of split your marks across all of these subjects, okay? So the first one is what's the independent and dependent variable? So the independent variable, well, that's the one that you're actually changing, remember? So this is the one that you change. So you're investigating how the current in a solenoid affects the magnetic field. So what you'll be changing is the current in the solenoid, okay? So you can write that as the current. The next one then that they want is the dependent variable. So this is the one that you're actually measuring. So what are you measuring? Well, you're trying to measure the magnetic field. You're seeing how it affects the magnetic field. So that's what you can write. So I'll just write MF. The next part then is how you'd measure the field. Well, what could we use to measure this magnetic field? Well, you can say actually one thing that you guys might be familiar with is compasses, so magnetic compasses. And so you can use this to measure the deflection of the compass, and that will give you an indication of how strong the field is. And the last one then is basically how to control the variables. So one thing that you could say is you want to keep some things the same, right? So these are your control variables. So I'll just write control. So there's a few things that you might want to control. So things like the number of coils in your electromagnet, the core of the electromagnet, and you could even also say the electromagnet length. So basically you want to use basically the same size and all the dimensions of the electromagnet. That should all be the same, and that should be considered control variable. And one thing you could also write here for kind of bonus marks is that you want to repeat readings, and you want to take an average of your readings, and that will basically help you to eliminate any anomalies, okay? And then the last question then is about transformers. So this is actually a very common one to come up right at the back end of these papers, is these transformer questions. And so we're told that a transformer has 800 turns on the primary coil and 200 on the secondary coil. Is this a step up or step down transformer? Well, you've gone from 800 turns to 200 turns, so this is actually what we call a step down transformer. And you can tell that because you have less coils on the secondary than the primary. Okay, so the next part of the question then, calculate the output voltage if input is 240 volts. So you want to basically use your equation where the V primary over V secondary is going to be equal to N primary over N secondary, okay? And what this is basically telling you is that the proportion or the ratio between the primary and secondary voltage is going to be equal to the proportion or ratio between the primary and secondary coils, or the number of turns on the primary and secondary coils. So we do actually have the information on the primary coil was 800 turns, so we can say 800 divided by the number of turns of secondary coil was 200. It's going to be equal to the primary over the secondary. And so we're told that the output voltage was we're going to calculate the output voltage, and the input voltage was 240 volts. So that means on the primary coil, we had a voltage of 240 volts. And the output voltage is basically whatever is on the secondary coil. You can write that Vs. And then essentially you want to rearrange for Vs. So because this is actually a proportion, you could just flip these around if you want. So you'd basically get 200 over 800 multiplied by 240 should give you the voltage on the secondary coil. If you plug that all into your calculator, you should get an answer of 60 volts. Okay, and so then the last part of our ChatGPT generated paper, explain why transformers are less than 100% efficient. So again, you're looking at energy losses in the transformer itself. And so where do they come from? So again, you could say energy is lost as heat, and you could say it's lost in the wires or in the core of the transformer. Remember, usually it's going to have an iron core. Something else you could also say is the idea of eddy currents. So eddy currents is basically these currents that get into the core, and these cause some magnetic losses, or they might cause some resistance in the core itself. And once again, it's a conversion to an unwanted energy form, so it's an energy loss, and this is what decreases the efficiency of a transformer, prevents it from being 100% efficient. Okay, so that's about it. That was the ChatGPT generated paper. Let's see how accurate AI is in predicting the paper 2 for you guys. Hopefully that video was useful. Leave a like if it was, and I will see you guys in the next one, and good luck with your exams.